So our sixth lesson is called Completing the Square, and that is where we use some algebra skills to help us find the maximum or minimum value, as opposed to the last 2 days where we've been using our skills to find x-intercepts or roots. So that's the big idea. Let's look at this one first using the graphing calculator. Y equals x squared plus 6x plus 5. So we're going to type in this equation. I go to the y equals button, and I'm going to type in x, square it, plus 6x plus 5. My numbers are on the smallish side, so I assume my domain and range are fine in the normal windows, but let's hit graph and see what we see. That's not bad. We don't need the domain to be so far to the right for our particular view, so maybe I will just change the x max to a smaller number like 4, just to see it a little better. There's my parabola. So we are going to draw a sketch of this, and I want to find just a couple of key values just so I can make my sketch a little bit more accurate. I'm going to find the x-intercepts, write them down, and the minimum this time because it opens upwards. So to find those x-intercepts, I'm going to find the zeros. I'm going to find the one on the left first. We're good at this because we've done it the last couple of days. And here's the first x-intercept. It is minus 5, negative 5 is one of my x-intercepts. It doesn't like to let me write when the document camera's on. There we are. Okay, my second x-intercept, so I'm looking for a 0, is way over to the right. So I want to be to the left of it. That's close enough. Enter. I want to be to the right of it, which happens to be above it as well. Hit enter, and I have another x-intercept of negative 1. This is just to help me do a good graph. I want the minimum value. So second calc, minimum this time, 3, because it opens upwards. So I want to be to the left of that lowest value. That would be just fine. And to the right of it, make sure you're at least confident you're to the right of it. There. And it will find the actual minimum value, which is at x value of negative 3, and the y value is negative 4. What absolutely beautiful numbers. So to draw a sketch from that information, I have an intercept here, 5, minimum value of minus 3, 4, and I know it opens upward, and I also know, because there's no a value there from my previous understanding of transformations in the first unit, that I open a normal pattern, over 1 up 1, over 2 up 4, bingo, over 3 up 9, and that would be the look of my parabola. So a rough sketch on a smartboard. There we are. The regular parabola pattern. Second question. We're going to show you a visual, first of all, of how we can change forms or write it in a different way. So if I have y equals x squared plus 6x plus 5, I could draw it as a picture with these algae tiles. The big X squared, the x's, and the 1's. So these colored squares and rectangles would represent the original problem. What I would like to do for completing the square is to fit my pattern of blocks into a perfect square and see if there's any missing bits or not, and we can find the answer to writing it in a different way. So bear with me for a moment here. I'm going to try and take these tiles and make a perfect square with them. So I'm going to move him here. I'm going to put a couple of these guys here. I think instead of trying to turn them, because they're kind of difficult. Come on, be nice to me. I told you. Well, I'm going to try All right, I had a little trouble with some of them turning on me, so I'm trying to make a perfect square with these blocks. And I'm going to just be a little bit short. So I might have to add a couple more to make this perfect square. Okay, so I'm pretty close, and I am missing one little guy. Really having trouble with this thing. 2, 3, and a fourth one. So I have all of a sudden changed and put 4 more tiles in there. So keep that at the very back of your brain. Notice that the area of this thing is x squared plus 6x plus 5 plus a little more. And I can write area as length times width. So if you look at the top, my length right here is x plus 3. And I'll move some little tiles over there to show you. So my length is x plus 3, and my width is also x plus 3. Oops, that's not the guy I want. And my width is x plus 3. Bear with me here. We're not going to do these little tiles for very long. But I have this little bit extra. So looking at my area diagram, I can say that x squared plus 6x plus 5 equals x plus 3 times x plus 3, but we kind of overdid it. So take away 4, because these 4 I kind of didn't really fit in there. I had to add them on the end. I could write that as x plus 3 squared subtract 4. Those two equations are the same because their area is the same. And this one we know from the first unit gives us our vertex as left 3, down 4. That is so much easier to graph if you know the vertex. The form that we were originally given, I don't know a whole lot from that form. This vertex form is so lovely. So our job today is to go from this form to that form. And the reason that completing the square works is that if you were to draw it as an area, it would be the same. So without tiles, we're going to do some completing the square questions, if I can get past them here. And I'm going to model how we would do that algebraically. So my goal for this question, I'm just going to write my goal underneath it, and I'm going to do the actual work to the right, would be that my equation looks like vertex form. So vertex form was ax minus h squared plus k. So that's my goal, to get it like that. Okay. Popping back to that last question. Notice that I had x squared plus 6x in the original question. And when I went down to vertex form, I had x plus 3 squared. I find that interesting that the first two terms I end up with half. So I'm going to skip a line on purpose. And I know that my vertex form that looks like that always has x add or subtract a number in brackets. And the last one that I saw, the number was half. That is always true. X plus 2 squared is going to be part of our answer. Now I need to determine what this number is on the end here. And that's where it gets interesting. I'll show you off to the side why you get this particular number, and then I'll show you what it is. X plus 2 squared itself is x plus 2 times x plus 2, which is x squared. I'm just doing FOIL. X squared plus 2x plus 2x plus 4, which is x squared plus 4x plus 4. So those two I wanted. Yes, but I kind of wanted a 10, not a 4. So what I'm going to do is take my x plus 2 squared and write what it actually is right above it. So I did FOIL and wrote it in there. And then I said, well, golly, I don't really want that 4. I'm going to get rid of it at the same time. Don't forget we used to have add 10. So I wrote in the 4, and then I subtracted it. If you add and subtract a number at the same time, it cancels out. So from line 1 to line 2, the question hasn't changed. It just looks different. The first 3 terms in blue are that perfect square x plus 2 squared, and the last 2 terms go together to give us that k value. Okay, it's crazy. I'm going to do another one. Y equals x squared minus 10x plus 11. So let's do this one first. I am going to skip a line and write my perfect square that I want for my vertex form. It's always x, add or subtract a number. And I noticed in the last 2 that it was half. So I'm going to put my minus 5. I'm actually close to done. I just need to know what this number is added on the end. So to do that, I have to go back up to line 2 and introduce a new number. Adding it and subtracting it to the equation won't change the equation. So x squared subtract 10x, then I'm going to add and subtract a number, and don't forget your 11. So what is that magic number that I'm adding and subtracting into the equation? Well, it's whatever the number is when you FOIL x minus 5. X squared outside inside minus 5x plus 25, which is x squared minus 10x plus 25. Ah, it's a 25. I need a 25 to make my x minus 5 squared perfect. So I'm going to introduce 25, but you can't just willy-nilly add a number to an equation, so you have to subtract 25 at the same time. The first 3 terms, x squared plus minus 10x plus 25, is this perfect square. The negative 25 and the 11 is going to be that elusive k value. So y equals x squared negative 10x plus 11 is the same as y equals x negative 5 squared subtract 14 in vertex form. So this one has a vertex at 5, negative 14. This form doesn't tell us a whole lot, but it does tell us that the y-intercept is 11. The last one is just a little bit uglier because 5 is an odd number. And I know I always want a square that's a half of that middle term. Well, we can do it. X plus half of 5 is 2.5. So I go back up to the line before and I think to myself, what is that number that I add and subtract to my equation? Well, that number is going to be whatever 2.5 times 2.5 is, which is 6.25. So I'm going to go back up to line number 2, and I'm going to write x squared plus 5x plus 6.25, because those 3 give me my perfect square right below. But I'm also going to subtract 6.25 so I don't change the question. Add 8. The first three terms give me this perfect square, and the last two give me my k value, 1.75. So this one's ugly. It has a vertex of 2.5 to the left and 1.75 up.